Hi everybody, this is Math 026. This is the lesson for Module 5, and this is going to be part 1 of 2. And in this part we are going to look at exponential functions. And an exponential function is defined as f of x is equal to a to the x power for all real numbers where x is for all real numbers x. So x can be, your exponent can be any real number. And a has to be, the base of that power has to be greater than 0. So you can't have a negative base. And a cannot be equal to 1. So for those exponential equations, you need a base bigger than 0, but it can't be 1. And you need an exponent can be any real number. So, think positive, negative numbers, decimals, fractions. They all work. So now for the first part, they want us to define, we have the function of x is equal to 5 to the x power. That's right here. And they want us to find f of 3. So f of 3, just like we did before with our functions, we would just substitute that 3 in for x. So we're going to do 5 to the third power, which would be the same as 5 times 5 times 5. And 5 to the third power equals 125. Now they want f of negative 2. So that's going to be 5 to the negative second power. And here we do still have to deal with those negative exponents. We don't like them. So we're going to take the reciprocal and make it 1 over 5 to the second power. And that becomes 1 over 25. Next we have f to the 0, or the function of evaluating the function at 0. So it would be 5 to the 0 power. And recall, anything to the 0 power always equals a 1. And our last one is f of 2.71. So we're going to do 5 to the 2.71 power. Now that's one I don't know off the top of my head. I wouldn't expect you to either. So we are going to go with the calculator and do 5 to the 2.71 power. And it is going to give me 78, and it gives me, it's not perfect, it's going to be a nice long number, but I'm going to round to 2 decimal places, so it's 0.380, so it would be 0.38. So 78 and 38 hundredths for that one. So next we are going to graph these two functions. We have f of x equals 3x. And so to graph this, we are going to, the best thing to do when you're asked to graph these exponential functions is we're going to do our t-chart. So we need x values. I'm going to do -2, -1, 0, 1, and 2. So I'm going to do 5 points here. 3 to the negative second power. If we recall, remember that would be 1 over 3 to the second, and that is going to give me 1/9, which we can't graph exactly, but we can estimate it. 3 to the negative first power would be 1 over 3 to the first, or 1/3. 3 to the 0 power, anything to the 0 power always equals a 1. 3 to the first power is going to equal 3. And then 3 to the second power is 3 times 3, or 9. So we're going to go ahead and graph those points. I have -2, 1/9. So again, you're estimating here, especially on here, it's a little hard. It should be real low. So it's right down there. -1, 1/3. So it's, still pretty low. It's not quite. That's more like 1/2. It should be a little bit lower than that. 0, 1. That's right there. 1, 3, and then 2, 9 is all the way here. So when I graph it, it's going to end up looking like this. And the thing with an exponential function is it will ride right along that x-axis, but it will never touch it. Exponential functions, they start off growing slowly and then explode. Kind of like, think about the pandemic that we're dealing with. it started off with one person and then it spread to maybe a couple more people and then they spread it and it just exploded. So it's growing exponentially. Let's take a look at g of x, which is equal to 1/2 x. And I'm going to again use the same t-chart as before. I'm going to do -2, -1, 0, 1, and 2. So if I do 1/2 to the -2nd power, I am going to make it positive, it's going to be flipped. So it will become 2/1 to the 2nd power. I'll take that reciprocal. Or 2 to the 2nd power is going to equal 4/1 or 4. Now 1/2 to the -1st power will become 2 to that 1st power. So it's going to become 2. 1/2 to the 0 power, anything to that 0 power always equals 1. 1/2 to the 1st power is going to equal 1/2. And then 1/2 to the 2nd power is the same as having 1/2 times 1/2, or it equals 1/4. We're going to go ahead and plot those points. So I have -2, 4, so that will be right here. -1, 2 is right here. 0, 1, 1, 1/2, so right about there, and then 1, 1/4. It's going to be a little bit lower. It's a little hard to do. And I'll go ahead and draw the line. And again, it's going to ride right along that x-axis, but never touch it. All right, so here we have the function of h of x is equal to 2 to the -x power. So again, when I go to graph this, I'm going to make my t-chart. And I'm going to use -2, -1, 0, 1, and 2. Now here, when I go to plug in my values, it's the opposite of x. So when I do 2 to the -2nd power, it's going to be 2 to the opposite. And then x is representing -2. So we need those parentheses in there. And that double negative, -1 times -2, is actually going to give me 2 to the positive 2nd power, or 4. And then we have 2 to the opposite of -1, so it's going to make it 2 to the 1st power, and that is going to equal 2. Now, the nice thing about 2 to the opposite of 0, the opposite of 0 is 0. Anything to the 0 power equals 1. Now I have 2 to the opposite of 1, which is going to give me 2 to the -1st power, or 1/2, because you flip it. And then finally we have 2 to the opposite of 2, which is 2 to the -2nd power, which is 1/2 to the 2nd, or equal to 1/4. Oops. All right, and we're going to go ahead and plot these points. So -2, 4 will be right here. -1, 2. And then we have 0, 1, 1, 1/2, which is right there, and 2, 1/4. And hopefully you're looking at this and be like, wait a second. I just did this, because we did. It's 2 to the -x power is the same as that 1/2 to the x power. So they should look exactly the same for your graphs. So we've talked about exponential functions a little bit, and we've talked about in the past section we did like inverses of functions. Well, now we're going to talk about logarithms and logarithmic functions. And a logarithmic function is the inverse of an exponential function. So a logarithm is defined as y equals the log of x with base b, if and only if x is equal to b to the y power. So notice, instead of having y equal to b to the x power, they switched x and y here. Because again, that's what inverses do. You switch your x and your y. And here, x has to be greater than 0. Y can be any real number. Or b has to be greater than 0. And we are going to go ahead and just look at writing each logarithm into an exponential equation. So again, we can take and convert this log form to exponential form. So if I have 3, or the log of 125 with base 5 is equal to 3. If I write it in exponential form, I focus on that base of my power first, and that base is the little number in the log. So my base is 5. My exponent is y, which is the answer to the log. So that's going to be my 3. And then x is going to be the big number with the log. So it's going to equal 125. So what they're saying with the log of 125 with base 5 is equal to 3 is that 5 to the third power is equal to 125. Do the same thing here. Look for your little number. That's your base. Your answer to the log is the exponent. And then the big number with the log is the answer to the power. So 2 to the negative third power is equal to 1/8. And then here we have 9 to the 3/2 power is going to be equal to 27. And remember, this is when we deal with rational exponents. Next, we are going to work on taking an exponential expression and writing it as a logarithmic expression. So just remember, if you have a log, it is the same if you have y equals the log of x with base b. It is the same as b to the y power equals x. So when we're going to do this, if I have 2 to the 5th power equals 32, I know that I need the word log. My little number is the base of the power, so it's going to be a 2. My answer is going to be my big number, and my exponent is the answer to the log, so not equals y here, but it's going to equal 5. So you kind of just, if it helps, highlight them in color to help you write it out right. So for my next one, for b, we're going to have the log of, and I'm going to put that little 64 there. The answer is the big number, and then it's going to equal whatever the power is, so 2/3. And then for c, let's put it down here, we're going to have the log of, and then we're going to have a little number of 81. So it's a log of 1/9 with base 81 is equal to negative 1/2. It's not too hard, it's just getting used to converting between the two. And the more you practice, the more you'll get used to it. All right, so here we are going to evaluate each logarithmic expression. Basically, they want us to find out what does it answer, what's the answer to it. So we're going to kind of look at an exponential form first. Here, if we have the log of 16 with base 2, that's going to equal, think of that as like your y. So really we're like, well, 2 to the y power equals 16. So with these are ones you're going to kind of be used to or know. So 2 to the what power gives us 16. And hopefully you're thinking to yourself, well, I know 2 to the third power is 8. So 2 to the fourth power is 16. So that one equals 4. Same thing here. Think 10 to the what power equals 1,000. And I know 10 to the second power equals 100. So 10 to the third power equals 1,000. For C, whenever you have a fraction, I want you to think, what kind of exponent are we going to have? What kind of exponent gives us fraction answers? Thinking negative, you're thinking right. So we have 3 to the what power gives us 1/27. Now here, I always focus on the 27 because that's what we're looking at. 3 to the what power gives me 27. And I know 3 to the third power gives me 27, but I need 1/27. So that means instead of a positive 3, it's going to be a negative 3. Same thing here with D. We have 6 to the what power is going to give me 136. So again, it's a fraction, so I'm thinking negative exponent. What can I do? 6 to the what power gives me 36. We know 6 to the second gives us 36, but 136 would be negative 2. So it's going to equal negative 2. Now for E and F, this is where we have 9 to the what power equals 3. Because my number is getting smaller here, this is where you're going to think rational exponents or think fractions. So really, for this one, I know to get 9, to go from 9 to 3, I'm doing the square root of 9, which the square root of 9 is the same as writing it to 9 to the 1/2 power, if you recall. So that means that this could equal 1/2. For F, we have 8 to the what power will give me 2. So how can I take 8 and make it 2? Hopefully you're thinking, oh, because we kind of talked about it up with A. If I do the cubed root of 8, it gives me 2. The cubed root of 8 is the same as 8 to that 1/3 power. So that's what it would equal here, 8 to the 1/3 power. And that is it for part 1. Stay tuned for part 2.